The problem we will be explaining today relates to a Blu-ray laser. We will each explain how to approach this multi-phase problem in an organized way to break it down for you. Part A tells us that the laser on a Blu-ray player has a wavelength of 405 nanometers. In what region of the electromagnetic spectrum is the radiation? What is its frequency? First, we must refer to the electromagnetic spectrum. We can find this in the textbook on page 284. Here is an expanded image of the visible light spectrum. It is evident through this image that the visible light spectrum spans from around 400 to 700 nanometers. Since the laser is said to have a wavelength of 405 nanometers, we know that it falls in the visible light spectrum.
The second part of this question asks for the frequency. We must use the following equation. C equals lambda mu. That is, the speed of light is equal to the wavelength times the frequency. To solve for frequency, we first need to put everything into the right units for our equation. We must convert our wavelength from nanometers to meters to match the SI units. We do this by taking 405 nanometers and multiplying by 1 meter over 10 to the 9th nanometers. This conversion equals 4.05 times 10 to the 7th meters. Using the values we know with the right units, we plug in and solve for frequency. The constant C has a value of 2.998 times 10 to the 8th meters per second. This is equal to 4.05 times 10 to the 7th meters times x number of hertz. We then divide both sides of the equation by 4.05 times 10 to the 7th meters and get a frequency value equal to 7.40 times 10 to the 14 hertz.
Part B tells us that the laser has a power of 5 milliwatts and asks us how many photons of light are produced by the laser in 1 hour. We are also informed that 1 watt is equal to 1 joule per second. The best way to start this equation is to use the equation E equals H times frequency. That is, energy in joules per photon is equal to Planck's constant times the frequency. We know frequency from part A, and we of course know Planck's constant, so now we just plug it in and solve for energy. X joules over photon is equal to 6.626 times 10 to the negative 34 joule seconds times 7.40 times 10 to the 14 hertz. We multiply it out and find that the energy is 4.90 times 10 to the negative 19 joules per photon. To find out how many photons of light are produced by the laser in an hour requires us to use the conversion provided to us in the question. We do the train track method and use dimensional analysis until our units of photons per hour. 1 photon over 4.9 times 10 to the negative 19 joules times 1 joule second inverse over 1 watt times 1 watt over 10 to the 3rd milliwatts times 5 milliwatts over 1. This gives us a result of 1.02 times 10 to the 16 photons. But we want photons per hour, so 1.02 times 10 to the 16th photons per second times 3600 seconds per hour is equal to 3.67 times 10 to the 19th photons per hour.
In part C of the problem, the question gives us a formula to use to solve for the resolution of a player using a laser. This formula is 0.6 multiplied by the quotient of the wavelength divided by the numerical aperture, which is the size of the spot of light on the disk. Using the formula given and dimensional analysis, we can solve this problem. We begin by converting 405 nanometers to meters. We do this by taking 405 nanometers and multiplying by 1 meter over 10 to the 9th nanometers to get a value of 4.05 times 10 to the negative 7th meters. We then find the resolution of the problem by taking 4.05 times 10 to the negative 7th meters, dividing by 0.95, and then multiplying by 0.6 to get an answer of 2.56 times 10 to the negative 7.
We are almost done with this problem. The fourth part of this question asks us to think about a physical disk and how many data bits the disk can hold. So we must use the area formula for a circle. That is, area equals pi r squared. Since we know the diameter is 120 millimeters, we know that the radius of the circle is 60 millimeters. The hole in the middle of the disk has a 15 millimeter diameter, so a 7.5 millimeter radius. 60 minus 7.5 millimeters is 52.5 millimeters. That's the radius. Now you plug that into the radius value for the area formula. And get 2,756.25 pi millimeters squared. The disk can contain only a certain amount of data bits in a given space. To calculate this, we do the following. 2,756.25 pi millimeters squared times 1.5 times 10 to the 7th bits over millimeters squared, which is equal to 4.1 times 10 to the 10th pi bits. Further, it asks how many data bits are needed for a typed page. We are given that a Blu-ray disc can hold 9,400,000 pages of text. This time you can very easily use a proportion. If 4.1 times 10 to the 10th pi bits can hold 9,400,000 pages of text, how many bits for a single page? So, 4.1 times 10 to the 10th pi bits over 9,400,000 pages of text is equal to x bits per page of text. Now we cross multiply. 4.1 times 10 to the 10th pi is equal to 9,400,000 x. Now solve for x. 4.1 times 10 to the 10th pi over 9,400,000 is equal to 1.4 times 10 to the 4th pi bits.